Bismillahirrahmanirrahim. In this video, I will solve problem 4.19 from the book Design and Analysis of Experiment by Montgomery, and I will solve this problem in Minitab. An aluminium master alloy manufacturer produces grain refiners in ingot form. So, grain size will be my response variable. The company produces the product in 4 different furnaces. So there may be different effects of the furnaces on the grain size. So the 4 furnaces become my 4 blocks. Each furnace is known to have its own unique operating characteristics. So any experiment run in the foundry that involves more than one furnace will be considered as a nuisance factor and we will have to block it. The process engineers suspect that the stirring rate, now this is overtreatment, affects the grain size of the product. Each furnace can be run at different stirring rates, so a randomized block design is used in particular. So we have this data, the treatment stirring rate, 4 different treatments, 5, 10, 15 and 20 RPM, and these are the 4 furnaces types. These 8, 4, 5, these are my response variable values or grain size values. Now I will input the data in the Minitab software. Please note that whenever you enter the data in the Minitab software, the first column should be for the treatments or for the column stirring rate, and then for the block furnace and then response variable. Since for each stirring rate, we have 4 different types of furnaces data available. So now what we will do, I will write here stirring rate 5 for the 4 times, then 10 for the 4 times. Likewise, I will write 15 also for the 4 times. Then I will enter the data for the furnace 1, 2, 3 and 4. Just copy these. So here we will do copy and then paste for the 3 times. Control V and here also Control V. Now grain size. Enter the data with respect to row 8, 4, 5, 6. So it's the most easiest method as per my knowledge. 8, 4, 5 and 6. Now after data entry, click on Stat, then ANOVA, General Linear Model. Fit General Linear Model, click on Response, Grain Size, click on Factors, Furnace, Stirring Rate, go to Graph, here select 4 in 1, these are for the assumption checking, then go to Result, here select the expanded table, because expanded table will give me the percentage contribution of each parameter on the response variable. So we got results. There are 4 different type of furnaces, 1, 2, 3, 4 and 4 different treatments, stirring rates, 5, 10, 15, 20. Come down and have a look at the residual plot. Double click on this plot so that you can view it only. So from the normal probability plot and frequency versus residual plot, it seems that data somehow following the normal distribution and it is fit for the analysis. This question has been asked there. Graph the residual from this experiment on a normal probability plot and then do the interpretation. So we have done it. Now we go up for the model summary. The model summary depicts that 67.74% variation in the response variable, that is grain size, has been explained by furnace and stirring rate. Now ANOVA table, analysis of various table. We have selected our significance level at alpha is equal to 0.05 or 5%. It means that if the p-value of any variable is exceed this significance level, it becomes insignificant. So it is quite clear that the p-value associated with the stirring rate is 0.323. That is quite higher than 0.05. So stirring rate is found to be insignificant factor. However, a very significant effect of around 72% variation has been contributed due to the furnace and it is also found to be statistically significant. It means that there is a significant blocking effect of furnaces on the grain size. Now, is there any evidence that stirring rate affect grain size? So the answer is no. The stirring rate doesn't affect the grain size because the p-value is greater than 0.05. Now part C, plot the residual versus furnace and stirring rate. Does this plot convey any useful information? Solve this part. Again go to Stat, ANOVA, GLM. You can do this part as well initially. However, for the sake of simplicity, I am doing it in two parts. Fit general linear model. Here in the graph, select stirring rate and furnaces, both of them. So we will click OK, then OK. We will get now two extra additional graphs. So the first graph is residual versus stirring rate. We have four different stirring rates: 5, 10, 15 and 20. So this is our least residual for the level 5 of the stirring rate, and this is the maximum value of the residual. Similarly, for the four different stirring rates, we have the variation explained in each of the level. Although the highest variation is at 5 and the least variation is at 10, but this variation is not too much high. So we can see that the variation among four different stirring types is found to be same or constant. Now we come down, and this is our second plot of the residual versus furnaces. Again, there are four furnaces: 1, 2, 3 and 4. The maximum variation is for the furnace 1 and the least one is for furnace 2 and 4. There will be differences in the variation for each of the level always. However, at here you got the least value of the residual at -3.5, the highest at 2.5. And for example, for one of the level, you got your values, all of the values that are very near to this central dashed line. Then it means that there is a difference of the variation among different levels for that parameter. In that case, the care should be given to the variation. So far in this case, variance is found to be constant and same. Now for the last part, what should the process engineer recommend concerning the choice of stirring rate and furnace for this particular refiner if small grain size is desirable? So this question is related to the optimization. So how we'll do it? Again, go click on stat, then ANOVA, GLM, then click on response optimizer. In response optimizer, we need minimize. So we want to minimize the size, then click on setup. In the setup, okay, the minimize target is 2, okay, fine, click OK. Then click on options. In the option, here select constraint to the region, because we have different levels of the furnaces. Also, we have different levels of the strain rate, and we want our answer within these parameter settings. Click OK. Then in the graph, please check that the optimization plot has been checked. In the result, all of them will be needed. Click OK and then OK. Wait for the result. We will get our prediction result. Now here we got the solution. In the solution, you can see that the furnace number 3 and the stirring rate 5, it has the grain size of predicted values 2 and the composite desirability is quite high of 1. The same thing has been predicted. The fitted value and 95% confidence interval based on this fitted value. Now these are the graphical result, and associated with this, these are the optimal setting: furnace number 3 and stirring rate number 5. Thanks a lot for watching the video. Have a good day. Bye.